here's another example of a optimization problem. We want to maximize the height of the rocket. So the height of the rocket time t seconds after fuel runs out, h of t minus 16t squared plus 96t plus 112. And we want to know the maximum height of the rocket and the time at which it occurs. Okay, so we can there's a couple ways of doing this, but we can first of all this equation, we assume it starts at time 0, and it's going to no longer apply once the rocket hits the ground. So so this equation is the height of the rocket at time t seconds after the fuel runs out. So at the moment the fuel runs out is time 0, and that's where the formula applies, starting at time 0, and it'll apply until it hits the ground. So let's find out when it hits the ground. We want to solve h of t equals 0. First step, solve h of t equals 0. So you have minus 16 t squared plus 96t plus 112 equals 0. And you can factor out the minus 16. And we have t squared minus 8t minus 16 and 112. Maybe it doesn't go 16. So 8 times 16. This is 60. Okay. And it goes 7 times, I think. 70, yeah. Okay, so minus 16 on the outside, and divide each term by minus 16. So 96 divided by minus 16 is minus 6. 112 divided by minus 16 is minus 7. Okay, okay, so then we can factor this into t times t is t squared. And we need two numbers to multiply to 7. Negative 7 add up to negative 6. And what works is plus 1 and minus 7. And you can check with the FOIL method. So that means that minus 16 equals 0, or t plus 1 equals 0, or t minus 7 equals 0. Well, 16 is not 0. Subtract 1, add 7, and you get t equals negative 1, or t equals 7 seconds. So the formula doesn't really apply going backwards in time. So it's going to so we're going to start time 0 and go up to 7 seconds. 7 seconds is when it hits the ground. So so that means that 0 less than or equal to t less than or equal to 7. So that's our interval. So we want to check for the critical numbers where the derivative is either 0 or undefined, and also check at the two endpoints, check the height of the rocket at the two endpoints. So let's take the derivative now. Second step, h prime of t. So if the exponent comes out in front, we'll have minus 32t plus 96. Minus 32t plus 96. And then we want to know whether that's equal to 0. So that means 96 is equal to 32t if you add 32t to both sides. And then divide by 32. And you get 3 is equal to t. So t is equal to 3 seconds. Okay, so so then we can just check the two endpoints, and that's the only critical number there. And so that the extreme values are going to occur either at the endpoints or at the critical number. So we just check T, H of T, check at time 0, 3, and 7. Well, we already know I'll write the equation here, minus 16t squared plus 96t plus 112. So at time 0, you're just going to have a 0 plus 0 plus 112, plug into the formula, be 112 feet in the air. Times 3, we already, well, no, we don't know. Okay, minus 16 times 3 squared plus 96 times 3 plus 112. 3 squared is 9. 9 times 16 is 144. It'll be minus 144 plus 96 times 3, I think is 288, plus 112, and it will give us 256 feet. Okay, and at time 7, we already know that's when the rocket hits the ground, so the height there is 0. So the minimum value is going to be when it hits the ground, and then the max will be 256 feet, and that occurs after 3 seconds. So the maximum height, 256 feet at time t equals 3 seconds after the fuel runs out. Okay, so that concludes this presentation.